Hey everyone, welcome back. Well, in this video, we will try to understand the horizontal scaling or scalability of Cosmos DB. So I'm pretty sure if you're following my videos, you know, I have discussed this concept of horizontal scaling and vertical scaling a couple of times. So in vertical scaling, what we do, we increase the size of that particular machine. That is vertical scaling. And whenever we perform the vertical scaling, it always requires the downtime. But in horizontal scaling, we keep on adding the machine to cater the request. There is no downtime required. So if you talk about VMSS, that is horizontal scaling, right? And app services that provides the horizontal scaling behind the scene, it keep on adding the virtual machines. But for example, you are running some virtual machine and you want to increase the power of that particular virtual machine, you change the skew of the VM, that is vertical scaling. So in Cosmos DB, we have horizontal scaling in place, which is like provides the capability of unlimited scalability for the Cosmos. So let's try understand that a little bit because we have to jump in the partitioning very soon, and all these bits and pieces that we are trying to cover till we hit the main or the huge topic, partitioning. It's important to grab this concept first. So in Cosmos DB, we have container. If you remember in the previous video, we talked about account, then database, and then container. So we have container and we interact with the container. We read the data from container, we write the data in container. Basically, container is the service through which we interact and we can store data, right? So behind the scene, these containers may have one or more physical machines. This concept of physical machine you will understand during the time of partitioning. Just to give you a brief idea, as I said, there is account, database, container. So the data inside the container is partitioned with the help of partition key in the uh, logical partition. And these logical partition is attached to the physical partition. Physical partition is nothing but the virtual machine which is taking care of those requests, the queries, or the database processing, those kind of thing, right? So even so, Cosmos DB containers is backed by the physical machine, and these physical machines are just like virtual machine or computer. They have their own CPU, they have their own memory, storage, and other resources which is required. We cannot see those machines because this is a PaaS service, more like a SaaS. We discussed that already. Not exactly SaaS, but kind of, because it provides a lot more functionality than just the platform. Okay, so we can't see those physical machines, but that's how it is designed, that we can easily read about it in the Microsoft documentation. So it's a Cosmos DB uh, which manage all these machines, and Cosmos DB uh, take care of how many machines are required for particular request, or like the data that you have uploaded, right? So accordingly, it keep on increasing the numbers of the virtual machine. So if we add more data in container, it's Cosmos DB which will arrange more machines. And there is no limit for that, how many machines Cosmos DB can arrange. So you see, if you require more, Cosmos DB is willing to give you more performance. So more data we keep adding in container, the more machines Cosmos DB will keep adding into the cluster. So whatever query we write, it would divide the work into these machines. More machines we have, more parallel query can work, and this is how Cosmos DB become horizontally scalable. Okay. So in this video, this is the concept that we needed to understand before we jump to the uh, a big topic, partitioning, which will require a couple of videos to cover. So yeah, let's start the partitioning, but then we'll talk about the geo distribution and multi-model and consistency. All of the important topics and interesting as well. So let's meet in another video. Till then, take care. Bye.